And also it's low enough to maintain some or sustain some irregularity, because Flatiron building is very small to be commercially viable. So this was a condition that was given. As I said, this tower was already built by another architect, but the same developer gave us a smaller site here that shared amenities below. So this was a taller tower. It has a bigger footprint. Our footprint was only 33 feet, which is about 10 meters. We always try to reflect the specificity of the given condition. So this represents the given condition. We had this site. Developer could build this blue amount, but developers didn't want us to go higher than 250 feet here, because if he thought that he would lose the contract that he already had with this building if we go higher than this. So we said, okay, after this point, we're going to move away from this building to preserve a view to the south. That made a building shape like this, which somehow resembled to a New York vernacular buildings caused by the zoning law. So this is the end result. Because it's because it's stepping like a New York typical building, it could look a very conventional New York building. Or it could look like a shy child behind his parents. Or it could look like a parasite. Or it could show its entirety. Or it could even look kind of straight from one angle. This is from 22nd Street. And this is from 23rd Street. And you can see how strange the building will be perceived. I refer to Flatiron building, but we also wanted to explore the potential of the mid-rise. Mid-rise has a certain amount of area that is manageable to have irregularities. In high-rise, it's very difficult commercially. So we decided to give a different heights and different windows to each level, which is also based on a structural issue. So in this portion, the structure is acting so hard that we had to give some wall space. So that naturally provides a kind of gradation from window to a curtain wall. So it acted like a corset. So it could change from a more big and punched window units and tall and more like a loft unit. This is strange, but the developer wanted to have a metal facade, but we convinced the client that because we wanted to have a concrete facade, concrete is already a hybrid of the metal and cement. So basically what we did is to have a polished stainless steel embedded in a concrete panel so that it catches the light in a very subtle way. In this building, we had the screening room at the bottom. Typically, any condominium, when they have an amenity like pool or gym or screening room, it always comes above the lobby or below the lobby. You will never see it unless you're the resident. But this screening room was for Creative Artists Agency, which is the biggest artist agency in the world, based in LA. And you name the film star, mostly they manage, they represent. Since it was a film business, we thought that it was nice to look at the potential of the stairs. Because the screening room has inherently, of course, the slope. So what we did is to use that slope and organize every possible thing that you need for the screening room along the slope, such as projection, seats, stage, lounge, and the entrance bar and code check into a single line that connected to the street. So you can see from the street each function, bar, lounge, seats, projection booth, and even to the other side. So when you are doing a pre-function event, you can have a drink at the front when you are connected to the city, and then you can go to your seat when the screening happens. This was at the height of New York condominium boom, so the units were very, very expensive. The cheapest unit was $7 million. So as a courtesy, as a kind of process of developer, we ought to make a showroom to show how the interior will be. But developer simultaneously told us that, you know, even if you make a showroom, no one gonna step into a showroom and buy a $7 million condominium. So in a way, it was just a kind of exhibition because their buyers were all just kind of celebrities. So we thought that we can do something. So they rented the space in Soho, this space, and basically we laid the building into the space, literally, shrink to fit. So this is the building laid down, and around the building there's a gallery. So this is the building. So you can see this is a gallery, this is you're inside the building. That made a very bizarre space with these kind of window patterns that I showed you. So that became a kind of showroom for us. But again, they never sold anything here. They did something else. We are doing also, those are commercial works, but we're also doing, of course, some cultural work. This is an extension of Cornell University Architecture, Art, and Planning. Their college is dispersed. It's housed in different buildings. And this is a typical American art squad. And this is the faculty that faces the north. And somehow, because this side is not facing the art squad, it was completely neglected when we started the project. So we thought that we can redirect that neglect and try to solve the problem that the college had simultaneously. So one problem was that the college was housed in a very linear Beaux-Arts type building where the flexibility was not there. And because these buildings were dispersed, the people were fighting inside the faculty, the professors. So we thought that we could connect these buildings and simultaneously provide a larger space where it could change over time. So that became almost like a mini art squad that is transplanted on the north side. Typically, any box is freestanding, as you know, in the suburbs. This box is defined completely by the existing building, this line, that line, as you can see. Even this line is defined by the alignment. It cantilevers over the existing road. In order to do that, we had to have such a heavy-handed truss to support. There are two ways to do it. One is a Vierendale structure, which is the straight columns, which causes a lot of money, or conventional truss, which is the cheapest solution, but that gives such a red part that has a kind of head height issue. So we thought that we could do something in between. So we calculated the moment of the building. And as you can see, when moment is low enough, we kept the Vierendale structure. And when the moment became high because of the cantilever, we made into a truss.